All right, so we're gonna, like I said, we're gonna talk about sequences and series. So today we're just gonna get a little introduction to sequences, and then we are going to write and evaluate what's called a recursive sequence. And so you may have never heard of recursive sequences before, but that's okay. There's one that you might have seen somewhere. Anyway, so a sequence is a set of numbers with a particular order or pattern. And each number is called a term. So one of the things we're going to do today is find the first 5 terms of a sequence. And so it's just like you plug in whatever and then you get a term. All right, there are finite sequences and infinite sequences. And I think you guys know what infinite means. What does it mean for something to be infinite? Never ending or unlimited. So a finite sequence is really what we're going to be working with. And a finite sequence is a sequence with a limited number of terms. And an example of a finite sequence would just be, we'll do a little brace, and then like 2, 4, 6, 8. That's a sequence. That's finite because it's limited. Right? And then an infinite sequence is a sequence with an unlimited number of terms. Right now, it's impossible to list an unlimited number of terms, but what we'll do is like we'll have like 0, 1, 2, 3, 4, and then we'll do dot, dot, dot. That means just continue that sequence forever. All right. One thing that is important to learn. All right. So one thing that's important to know is the notation. And so anytime you see a and then like a subscript of 1, that means the first term. All right. And then each subsequent term is like a sub n, where n is the number of terms. So for example, if you see a sub 2, that means the second term. And a sub 3 means the third term. All right, so on this example, we have a sequence, and it asks us to find a sub 1, and that just means to tell what the first term is in the sequence. So what do y'all think? 1, good. Right? And then a sub 4 means to tell what the fourth term is. So 1, 2, 3, 4. The fourth term is 13. Right. And then a sub 9 is the ninth term. Now we only have 5 terms, so we're going to have to continue it. So what's happening each time on this sequence? We're adding 4. So the fifth term is 17, and then we just add 4. Good. And so that's the 6th, and then 7th, and then 8th, and then 9th is going to be 33. And then I'm just going to keep on adding 4 until we get to the 12th term. So the 12th term is going to be 42. All right. Now, I think, 45. I just wrote my 5 upside down. Now, because each term value is paired with exactly one term, then a sequence is a function. And in this function, the domain is the set of term numbers. And the range is the set of term values. Right. Now, we really aren't going to do a lot with infinite sets because they're no longer in our standards, but I'm just going to go ahead and fill in these blanks since we're here. But an infinite set is, again, the domain is going to be the set of natural numbers. Now, back in pre-algebra or maybe algebra 1, you learned about sets of numbers. Whole numbers are like 0, 1, 2, 3, 4, 5, 6, all the way to infinity. Natural numbers is that list without the zero. So it's like the numbers you learned when you learned to count. Those are the natural numbers, and they just keep going up by 1. All right, so let's talk about recursive formulas. So a recursive formula is a rule in which one or more previous terms are used to generate the next term. So there is kind of a famous sequence that's called the Fibonacci sequence. Fibonacci is actually that mathematician I have in the back of the room, the yellow guy. That's Fibonacci. And if you guys have seen the movie, I forgot, Da Vinci Code, or read the book, the Fibonacci sequence is in that movie. But anyway, I'm going to show you Fibonacci sequence. I'm going to see if you guys can figure it out. So the first term is 0, and the second term is 1. All right, and then it's 1, 2, 3, 5, 8, 13, 21, 34, and it goes on and on. So after you get past the first two terms, can you figure out what you do to get the next one?
The next number is the additive of the two previous.
Very good. So you add the two previous numbers to get it. All right, so 0 plus 1 is 1. And then 1 plus 1 is 2. And then 1 plus 3 is 1 plus 2 is 3. So it continues that pattern. Nice. That's Fibonacci sequence. All right, so I'm going to show you some more notation for previous term. So anytime you want to represent a previous term, you still have A, which is like our symbol for term, and it's the subscript is n minus 1. So A sub n minus 1 means the previous term. So I'm going to show you how to write like the rule for Fibonacci sequence. It's up there. It's kind of hard to see. He uses F instead of A, but it's at the top. You can't really see it. But anyway, so on this one, you have to tell the first and second terms. And then to get the next term, which is A sub n, you're going to take a previous term, which is A sub n minus 1, and add the term previous to that. So how can you represent the one before A sub n minus 1? It's kind of a tricky question. Do you guys know what the subscript would be, the one that's before n minus 1? That's okay. It's n minus 2. So that's adding the two previous terms. All right, so we're going to do some where we're finding the first 5 terms, and then we're going to do some where we write the rule. So on this first example, we're going to find the first 5 terms. And they told us one term, so that's good. The first term, this right here, A sub 1 is 14, means the first term is 14. So we just need to find 4 more. All right, so this notation right here means previous term. So what are we going to do to the previous term to get the next one? Not subtract. No, that whole a sub n minus 1 means the previous term. So what's it? We're going to add 9. So to get the next term, we're just going to add 9. So the first one is 14 because they tell us that. You have to be told that. And then we add 9 and get 23. And then we add 9 and get 32. And just keep adding 9 until you have 5 terms. That's it. Now, sometimes they're more challenging than that one. Like there's more stuff you have to do, but that's pretty much how you do it. All right, so let's look at number 2. It's a little more complicated, but we still already know the first term is 6. So we got that. And then this tells us what to do to the previous term. So what's the first thing you're going to do to the previous term? That's the second thing you're going to do. So the first thing you're going to do, it's okay, is multiply by 2. So 6 times 2 is 12. And then you're going to subtract 5. So that's 7. I'll go slower this time. All right, so this time, this is going to be 7. This right here is going to be 7. So it's 7 times 2 is 14. And then minus 5 is 9. And you can do it in the calculator if you don't want to do it in your head. You don't know how I got 9? Okay.
How did you get 7?
Okay. So the first one is 6. So then I'm going to put the 6 right here. That's going to be a 6. So I'm going to multiply 6 by 2.
But those aren't the same.
What's not the same?
They're not like a n minus 1 equals
This is the previous term.
Yeah, but a1 is in a previous term.
Yeah. If you want to find the second term, the first term is the previous term. Does that make sense now? So now to find the fourth term, the third term is the previous term. Okay, good. So 2 times 9 is 18, minus 5 is 13. And then the fifth one, the fourth, is the previous. That's 26, minus 5 is 20. Everybody okay? Got some light bulb moments. Those are teachers' favorite things ever. Oh, sorry. All right, so let's look at number 3. This one's kind of complicated, but we know the first term is 354. So to find the next one, we're going to take it, 354. We're going to add 6 to it, so that's 360, and then divide by 3. Should be 120. All right, and I'm going to take 120. It's going to be here. I'm going to add 6 to it, so 126 divided by 3.
So you just keep on doing it.
Mm-hmm. So you get 5 terms. So we're going to take 42, add 6 to it, and then divide by 3. Yep. Okay, and then finally, we're going to take 16 and add 6 to it, and that's 22. And that doesn't divide evenly. So if it doesn't divide evenly, you can leave it like 22 over 3 if you want to. If you wanted to give the decimal, it's okay, but you can just leave it. All right, we're going to do one more of these, and then we're going to write the rule. All right, so here we go. This one's a little different, but it's nice. They gave us the first 2 terms. Whoops. 3 and 4. So we have 2 out of the 5 that we need to find. So this one's kind of like Fibonacci, but instead of adding, what are we going to do? We're going to multiply. So to find the third, you're going to multiply the 2 previous. So what's it going to be? 12. Yes. And then we're not laughing. It's fine. And then to find the fourth, what are we going to multiply, Nolan? What are we going to multiply?
4 and 12.
Good. So it's going to be 48. Now this last one, I can't do in my head. Thank you. And we multiply 12 times 48, 576. All right. Any questions? You guys are doing great. Okay. Couple more. So on number 5, we are going to write the rule. Now I can tell on both of these that I changed it from the original. I must have not liked what it was, but it's fine. I made it better more than likely. So when we write a rule, a recursive rule, we do have to tell what the first term is, but that's easy. So just write what a sub 1 is. All right. Then we're going to tell what to do to that to get the next one. So can you guys tell what's happening each time? Subtracting 3. So you have to say the previous term, and anytime you want to say previous term, it's a sub n minus 1. And then, like he said, we're subtracting 3 each time, so then you just subtract 3 from that. All right, y'all okay? All right, let's look at the next one. All right, we're going to write the rule. Oh, hold on. We're also going to find the next 3 terms. I didn't follow all the directions. So after -5, we're just going to keep subtracting 3. So that's -8. And then just keep subtracting 3 until we get 3 additional terms. Huh? I just continued the pattern for the directions, say, to find the next 3. So we're subtracting 3 each time, so I just kept subtracting 3. Okay, let's look at this guy. We want to tell what the first term is. All right. And then what are we doing each time? Right. So you can say you're taking half, or you can say you're dividing by 2. Do you guys care which one? Taking half, dividing by 2, dividing by 2? Okay. So we're going to take the previous term and divide it by 2. Or if you would rather, you could do 1/2. Whichever one you want. You don't have to write both. All right. Now we're going to keep on dividing by 2. Now this is decimals. I honestly would rather divide fractions than decimals for me. It's just the way my brain works. But I'm going to just divide by 2. And then that's already my calculator. So I'm just dividing by 2 again. And then one more time. So 3 additional terms. All right. So that's it for today. Do you all have questions on recursive sequences? Okay, so this packet is going to be a 3-day packet. And so today, if you flip to the page that's your homework page, it's just 1 through 6 today. And you can hold on to it today because you don't have to turn it in until we're completely done.